neural network. The contains basically algorithms. Our proposed algorithm, which is a hybrid model, gives the best results, which is high accuracy results rather than the two algorithms. And this is the graph for the three algorithms. We are plotting the graph for the three algorithms by using the evaluation metrics like accuracy, F1 score, precision, and recall. This is one output for the hybrid model outputs. First one, the user can enter attributes like age, gender, disease. Then it will give the output like morning meal, afternoon meal, and night meal. And we also create a charter by using NLP so that the user can also know how to make a recipe. So this is one of the recipe consciousness biryani recipes. How to make it. And this is one of the recipe preparation for ice creams. And when coming to the conclusion, it adapts to user health preferences and real-time feedback. Mainly, NS is an advanced adaptive food recommendation system such that it supports multiple charter temperatures and also outperforms the traditional models. In future, also we aim to integrate with images by expanding the analysis support and use image-based food recommendation. And finally, we are considering so many reference mappers so that each algorithm gives the most accuracy. So that by considering all the references, we consider the ideal model. Thank you, sir.
How much data is needed for this accurate optimization?
Sir?
You have taken some data. So how much data is needed for more accuracy of your results? And what will be the optimization technique you have applied here?
So, we are using two data sets mainly for food recommendation and recipes. So, by getting the two data sets which are provided in candidate, we can gain the more accuracy.
What are the major parameters of your this machine learning algorithm you have used? Which machine learning algorithm you have used in this?
Collaborative filtering and the context-based filtering, sir. For collaborative filtering, it is similar, percent similarity, sir, which is by using the user interaction, it can learn the user patterns, sir. And coming to the context-based filtering, we are using the user inputs like age, gender, disease, so that it can easily recognize that and give the more accurate results, sir.
This hybrid model, why is hybrid?
Hybrid means yeah.
Hybrid model you have used. What is this hybrid model?
So hybrid model means by combining two algorithms. One is collaborative filtering and second one is context-based filtering.
These are different algorithms. These are separate algorithms. So why is it named as a hybrid?
These are two different algorithms, sir. But in our proposed system, we combine those two algorithms, sir, for better outcomes. That's why it is named the hybrid model, sir. By making there's two models, sir.
So what assumptions you have taken here in your this this machine learning algorithm, what type of assumptions you are taking? Totally accurate or there is some drawbacks?
There are some there are some drawbacks. The first one is data quality, sir. By considering the various number of diseases, it cannot provide the accurate results.
In your algorithm, you have taken some assumptions. What type of assumptions you have taken?
So first is the user data is accurate and consistent, sir. And one more is health condition affects the by taking the food recommendation of itself, sir.
Rohit sir, you want to ask something?
Sir, a very basic question, Kishore. For your system, in one of the slides you've shown what are the inputs and what is the output.
So,
Yeah. So from this slide, can you tell how you are calculating the accuracy of the system? Because it's a recommender system. For the recommender system, how we can calculate the accuracy? Because in your output, you are getting some mean recommendation only. So how we can say that mean recommendation is correct or incorrect? So the recommendation is recommendation only, no?
sir, this one, sir. This slide shows the training hypothesis it gives the accuracy.
See, hold on. See, whatever the model you will take, the model don't know what is the output. Whatever you fed to the model, it will take it as the output. But as a user or maybe as a developer, you must know now what is the output actually. So, for your recommender system, you are saying your system will tell whether you should take veg meal, non-veg meal, or this calorie meal, whatever it is. But how do you decide the true value, whether this is correct or incorrect? How you decide? See, in general, let's say, if you are going to predict some disease, so your true value will be either the data, whatever you are predicting, is having the disease or not. So then you can test your system, you can tell the accuracy. But for this system, how this accuracy or these parameters are applicable to assess the performance?
Yes, sir. We are considering after the results, we are also talking the confusion matrix and loss functions, sir.
That is all okay. See, confusion matrix, with the confusion matrix, you are just estimating that precision, recall, F1 score, all those parameters. That is okay. My main concern is accuracy you can calculate when you know the true value. And with respect to this input, output should be 0 or 1 or maybe some value. But if it is a recommender system, how we can tell whether it is actually what is the that true value? How you will decide, okay, this person is having this type of disease or age or male or female like that input. The person should have the veg meal or maybe the non-veg meal with that much calorie or something. How you will decide where you will get the true value for that?
So we are asking if the user can enter attributes like age, gender, and disease, and it gives the output like some food recommendation.
This is what your system is doing now.
Yes, sir.
So that's what my question is. How you are calculating the accuracy?
So
Okay, just go to that slide where you have shown the output.
this slide, sir.
Yes. So let's say for some of the given input, you are getting morning meal, some quinoa breakfast. So how you will decide whether your system is telling you correctly or incorrectly? It is correct or incorrect? Is it accurate or not? How you will decide that this recommendation is okay or not? Okay, so don't worry. See, these are some of the basic things that you should take care when you are going to start some work. Okay. Okay, so I don't have any further question. So you can like just unshare your screen and we can go to the next PPT. Thank you for joining.
Thank you, sir. Paper number 203. Please be ready with your presentation.
Good evening, sir. So, am I visible?
Please turn on the camera.
Okay. Yes, I'm just run out.
He has done it probably. We can but there is a mistake. Line number 40.
So, my screen is visible, right?
Yes, you can go to flight mode.
Yeah. So, my screen is visible. Like, yes, right? Okay, so very good evening to all the respective authors, all the members, and all the researchers.
Please go to presentation slide mode.
Actually, I have started slide mode earlier, but I can share my entire screen.
Yes.
I got it. Alright, is it visible, right?
Yes.
Okay, so very good evening to each and everyone present here. I am Ashifat Patel and I am currently pursuing my Masters in Technology from Computer Science Engineering branch from NIT Allahabad. And today I am here to present about my research paper, which is based on enhancing the suicide and depression detection through social media text with the use of deep learning models. So this topic is entirely focuses about the prediction of the mental health problems. For example, nowadays we can see that we can see the problem of depression, anxiety, and other mental health related problem in the youth particularly. They are confused with a lot of stuff. So here we have utilized the text or the thoughts that they have shared on the social media, and with the help of that we are trying to predict whether particular youth is suffering from mental health problem or not. So these are the table of content. I will be explaining you what is our problem statement and why we are doing this, then the research objective, then how we occupied our data set and how we pre-processed it, then the word embedding that we have used, which is fast text word embedding, why we used it, finally the architecture that we have employed, which is deep learning architectures. Then I will discuss the result and finally compare with the other models, and finally I will conclude and what future things could be done in this. So each year almost 280 lakh plus people suffer from depression, and these are just the official number from WHO. And when coming out to suicide, more than 700,000 people commit suicide every year, and this problem is increasing every year. You can see here from the map that the countries like all the developing and developed countries like America, all the Europe, India, and Australia. So here the percentage that the people are suffering from depression is quite a lot, and it is increasing from time to time. And this is happening because we are unable to detect in the early stages only that whether a particular person is suffering from the mental health problem or not. So the symptoms that includes these problems are persistent sadness, fatigue, lack of interest, and often their disinterest in the daily life. So this is the main objective of this research, to early detect that whether person is suffering from mental health problem or not. So this is the objective. So here we have employed the Reddit dataset. So there on the Reddit the youth and other people have shared their thoughts that what they are going through in their day-to-day life. So we have employed that dataset and we are trying to predict whether a particular person is suffering from some of the problem or not. And in this we have used deep learning models which are based on the neural networks and employed the features of back propagation. So various deep learning models like CNN, RNN, LSTM, BiLSTM, and at large hybrid models which are giving the best results. And here the word embedding that we have used is fast text. I will explain you what is word embedding and why do we need it. And finally the performance matrices, which is accuracy, precision, recall, and effort score. So coming on to the data set. So data set that we have used is from the Kaggle data set, and it was published in year 2021. So this data set consists the data from last 15 years, and it has almost 3 lakh entries, in which half of them are depressive text and half of them are non-depressive text. So this data is very diverse and we can really use it all the subreddits, the people have shared their thoughts. So in the pre-processing stage, we have learned the steps like tokenization, lower casing. So tokenization is splitting entire sentence into particular tokens. Then lower casing is like converting the capital letters into the entirely smaller ones. Stopword removal, like removing of the word like it, of, and etc., which are not necessary. Finally, stemming is converting the word to their root form. For example, runner. So runner will be converted to run, and so on. Similarly, lemmatization, and then, for example, the sentence "I can't do this anymore" will be converted to "can't anymore," because these are the important things related to mental health. Now coming up with the fast text embedding. So what is embedding? So in field of NLP, what happens is that that we are the text that we are giving to the system, we need to convert it to some form of symbols, or we can say some form of tokens, so that the model could understand that what is the value of each of the tokens and so on. So there are various forms of embedding like fast text, love, word to back, and so on. And we have employed the fast text embedding. Why? Because of some of each feature, which includes the first one is subword representation. So in fast text, we are able to, there is a feature known as n-gram. So what is this n-gram? For example, a word like classification. So if we divide it into 3 gram problem. So here it will be divided into three word, 3 letters, subwords. For example, CLA, LA, AS, ASS, and so on. So by this feature, if even the spelling of the word in the dataset is wrong, still it will be able to understand it properly that yes, this word is classification. So this is the subword representation. Second is handles morphologically rich language, which means it can understand, it has the understanding of vast semantics. For example, running, runner, ran, etc. will be converted to the root form only, which is run. And third one is context level embedding, which means it is able to understand that what is the context of the sentence. For example, I went to the bank to deposit money, and I sat by the bank of the river. So here the word bank will be here the in first case bank will be represented with the will be matched to financial institution, and in the second case it is a river bank. So that using fast text would smoothly realize that which is the context of the problem. Now coming to deep learning architecture. So deep learning in its root employ the feature of neural networks. So in neural network, we have a concept of back propagation through which we reduce the errors with each of the flow, and with time the model learns. So there are various deep learning models, and we have tried to employ each of them so that we could find the best results. So first one is CNN. So CNN there is the concept of filters, which is convolutional filters and then kernels and so on. So in this the all the tokens that were generated by the fast text, so each of them were passed to the filters. Then these filters were recognizing the local patterns. For example, the words like and everything, feel along, these are the depressive words, depressive tokens. So this was successfully identified by the CNN model. So but the disadvantage was the losing gradient problem. Like with this, it was not able to recognize the pattern for the longer period of time. The second model was RNN. So RNN also suffer from backstreet gradient. The advantage of using RNN is that it has an internal memory stage, or we can say recurrent, which means it has the ability to learn the context of the previous word. For example, here I am not feeling well. So here the word not feeling could be remembered by the RNN model and like it provides the advantage. Like we can get to the concept, but it also suffers from backstreet gradient problem. So, then we have employed LSTM model. We solve the vanishing gradient problem. It uses 3 gates: this target gate, input gate, and output gate. So,
please go fast. There is a limited time.
yes, sir. Sure. Okay, so then LSTM model, similarly bi-LSTM model. Bi-LSTM model is nothing but LSTM from both the sides. Finally, we have deployed the hybrid model, which is utilizing the advantage of both RNN and LSTM. RNN is remembering the pattern, and bi-LSTM is remembering it for a longer period of time. So by using this hybrid model, we have got the best result, which is the accuracy of more than 91%. So these are the results. So the best model that we have found is RNN bi-LSTM model with accuracy of 92.36%. So it bypasses all the traditional ML classification algorithm like SVM, logistic regression, which have result less than 90%. So we have implemented all the models, and we have presented the detailed comparison result in our research paper. Right. So in the future, we can enhance this system further by utilizing the multimodal inputs, which is giving the input in the form of text, videos, and so on. And and other we can also utilize the real time detection system. So yeah, thank you, and I'm open for any questions.
Okay, Ashivad, can you explain what is the why LSTM and how it is different from the LSTM?
Yes, sir. So in the slide, as the time question time. So here, LSTM is LSTM from both the directions. So here, the forward LSTM captures the pattern from the one side, and backward LSTM captures from the other side. So that means that the better pattern recognition. For example, I didn't mean to end my life. I just wanted to the pain to stop. So here the sentence is very long. So for the LSTM model, it would be difficult to capture all the pattern. So in forward LSTM, here it captures the emotional build-up, which means the pain to stop, and backward LSTM would be the meaning from the later word, like combining both the sub sentences and giving the complete pattern recognition. So it is LSTM from like both the sides.
Means you can apply the input at both ends.
Yes, like we can apply the input at both the end, not input, like we have already given the input, which is a sentence. We can apply the model at both the ends, we can say. So the representation, we can feed the representation from both the directions, like forward and backward.
So you have not presented any mathematical modeling, and from where you have generated these results that which one is better. So how you have compared it?
Yes, sir. So the comparison was basically from the performance matrices, which was like all the matrices like accuracy, precision, recall, and F1 score. So the detailed chart was presented in the research paper, and sorry I didn't include it here. Like I missed it, but like the chart was presented. The comparison was basically in the form of like performance matrices only, like which has better accuracy and all the other recall, F1 score, precision.
Means you have to present some mathematical modeling as well. Okay. So if Rohit
Yes, sir. I am. Yes.
Okay, so Ashwat, there is very basic question. Like you must be using some data bank, like or emotional analysis. You must be having annotated some words.
Data means by data type you means the data set that I'm using.
Data set or maybe let's say if you are finding some particular word in your analysis, then you are correlating it with some emotional condition.
Yes, sir.
Okay. So how you are identifying those words? Is there any step database that you are using, or you have created your own?
No, sir. So that thing actually we don't use because the embedding that we are using, it by default does that thing for us. Let me explain you with the example. For example, the sentence like I am very sad. Okay. So I am very sad. So here the token very sad would be given a particular weightage. For example, 0.95. And similarly, I am sad.
That I understand. So now my question is, for that word very sad, who decided that it will be given higher weightage? The system will
It
decide.
has been decided by the yes, sir, the embedding will decide because the data set that we are giving is very large. So the training, so here training has been done in two parts. First one is the embedding part because so that thing you are saying that giving the more importance to the words, attaching the meaning to the words. For example, sad, depression, then mental health, and so on. So the embedding thing would attach the importance to these words, and then the model would find the patterns from the like sentences.
Okay. So in that case, just tell me what is the novelty in your work? Like what is your contribution apart from the existing work? Because let's say the model is already existing, this type of techniques are already existing. So what is your contribution?
No, sir, the thing was that the like research that I found on this topic was mainly based on the ML techniques, ML traditional ML approaches like support vector machine decision trees and so on. So the basic advantage of neural networks like there has not been proposed
the NLP, so at the back end you are using some neural network only.
Yes, sir, in the embedding part, yes.
Yes. So okay. Anyway, so overall good presentation. So thank you.
Thank you.
Thank you for the presentation.
Thank you, everyone. Thank you.
Next paper ID 216. Next presentation is of paper ID 216.
Yes, sir.
Minachi, you can present your PPT. Let's start.
Yes, sir. So share option is not working. Hello?
You can try again once.
Yes, sir. Yes, sir.
There is an arrow given. So just from there you can share your PPT.
Yes, sir. This share box is sorry, available.
Sir, can you please click on your there may be an option of selecting your screen and then the option will be enabled on this.
Sir, I'm checking with window and entire screen both, but दोनों में ये enable नहीं है मुझे share वाला.
एंटायर स्क्रीन में क्लिक करके आपके पास एक कुछ बॉक्स जैसा कुछ आ रहा होगा, वहां पे क्लिक करना पड़ेगा. ट्राई कीजिए. जो विंडो है वो छोटा सा दिख रहा है.
Okay, sir. Okay. Is it visible, sir?
Yes, sir. Yes, Minachi, it is visible.
Okay, thank you, sir. So good evening, everyone. My name is Meenakshi, and I'm a PhD research scholar in Kshetra University, Kshetra, and my research topic is improved predictive healthcare with imbalanced data, machine learning to predict thyroid cancer recurrence. So this topic is discussed into these 5 sections: introduction about healthcare and work done in the field of healthcare with machine learning models and the methodology that is used by us, and what are the results and the conclusions. So healthcare is a very important sector for any country, as it focuses on physical and mental well-being of an individual, which will ensure healthy population to contribute in economic growth of the country. There are several technologies that have transformed this healthcare into smart healthcare, and machine learning is one among them. Machine learning has been used on different types of data that are available in healthcare, like for electronic health records, in medical imaging, clinical decision sports, and for several applications. And these applications can be found from the study of the literature. Machine learning models have been used in these different types of applications, like for anxiety prediction, depression, stress predictions, chronic diseases. In these different types of healthcare applications, several types of machine learning techniques have been used. For our problem, we have considered this thyroid cancer recurrence problem. From the studies, it is found that it is among the most common diagnosed diseases for which cases further are increasing. The data set that we have used for this disease is available on the NCI repository, and it is a structured data set, and it does not have any missing values. There are total 83 instances in this data set. It has total 16 features which include personal detail of the patients and their clinical record, personal details like their age, their gender, whether they do smoking or not, whether there is a history of smoking or not. And in clinical records, it included features like what is the stage of the cancer, what is the size of the tumors, whether there is any lymph node or not, or what about the metastasis processes. Including other features also. So these are the predictor variables, and for the target feature we have this record variable, which is a binary feature, which will tell whether the patient will have the reoccurrence of this disease or not. Then among these features, we have one feature which is numeric, four are binary having yes and no value, and 11 are categorical feature which can give which represent different category for that feature. And for the target variable, we can see here that there are 108 instances for the class and 275 number of instances for the no category. So there are almost more than twice instances for this second no category as compared to the yes category. So we will try to handle this with our stratified sampling. And then we also grouped our age, which is a continuous attribute here, into 5 groups. These are the number of instances that lie in each group. And we will use this when we apply group K fold, where we will train our model on a different age group of patients, and we will test it on a different age group of patients. This is the methodology that we have followed. First, we pre-process the data, then the model selection, then we fit the model, and then we assess the model with different metrics. And the data is processed as first it is split into train and test data. Then from this train data, the model is fitted, and the various fold for different CV strategies are formed, and the models are fitted from these folds, and the metrics are generated for both types of models. So these are some data processing tasks here. All the categorical features are converted into numeric features so that they can be processed by the ML model, and they are also standardized with a standard scaler. Then data is sets are generated as described previously. Then for model selection, these are the 3 sampling techniques. First one is the K-fold. In the K-fold is not affected by data and groups. It mainly generates a number of folds, among which K minus 1 are used for training the model, and the remaining one will be used for testing the model. And in stratified K-fold, first of all, it prepares a strata by including equal proportion of each class of yes and no category, and then the train and test group folds are prepared with these strata. And in group K folds, it will prepare groups, and when it divides data into train and test, so it will ensure that the same group will not be included in the train and test. Then the model is generated with this SVC classifier. SVC classifier, it is a supervised learning algorithm, and it has this regularization parameter which will give a customization, like C will help in having in selecting whether we want a better margin or better generalization. It also provides several kernels. We use here RBF so that we can have non-linear decision boundaries, and the gamma parameter is set to scale. The model is assessed with these metrics: accuracy of one score, precision, recall, and ROC. These are the results where for the SVC model that we have formed for both train and test sets. From there, we can see that the accuracy value, F1 score, precision, and recall value, all these values are in acceptable range for the train test as well as for the test dataset. Though there is some reduction when we move from train to test set. And this is the ROC curve, which is again high for the train data set, and less for the test data sets, and same for the AUC, the area under the curve, which is larger for the train set and less for the test set. Then the results for the cross validation strategy for the we can see here the for K-fold and stratified and group K-fold, all the values of this accuracy are same as in the SVC, and the value of the test is more than the SVC model. And same for F1 score, where we have good value of F1 score for all these strategies. Same for precision and recall. Here, the SVC model have a good metrics, as the dataset is very small, and SVC perform always give good accuracy. Generally give good accuracy when we use smaller dataset on it. And K-fold is mainly it will provide the generalization for the model, and it will also reduces the overfitting of the model. And then this stratified K-fold where we handle this class imbalance by taking the equal number of samples from the data sets, and group K-fold where we make sure that we will train our model on different data on different age groups, and we will test it on different age group, and all these models performed well on this data set, and the model maintained its performance. Then the conclusion, here we have developed a robust predictive model to predict the disease recurrence. The imbalance strategies handled with sampling and cross validation strategies, and overall the proposed approach improves the healthcare services and this is the next. Thank you.
Okay, Yakshi, what is this imbalance data? Means, what you can say that this data is balanced and this is imbalanced?
So the data imbalance is mainly here according to the classes, the target class that we have, where there are more instances for a category and less instances for other category. So model will train model will have some biases for that category for which we have more number of instances. So in using these techniques, we are trying to have equal number of instances for both of these categories. And in group balance, where we are considering all groups to be included in the train and test, and we also make sure that the group for which the model is trained, it should not be included in the testing model, so that there will be no biasness according to the group.
But in your presentation, just show some block diagram so that we can easily understand what we have done. Okay, so all of these things are good, but you have to present all the work by some block diagram or some mathematical analysis, some mathematical model you have to present.
Okay.
One more question I want to ask: what is this ROC? You have mentioned somewhere ROC.
Yes, sir. Receiver operating characteristics. It is to show the relationship between true positive rate and false positive rate. That is the value that we get from TP, FP, and TN and FN.
So for all these whatever you have used this K-fold and stratified K-fold models, so just you have to compare it by a table and some mathematical modeling you have to show, so that we can easily compare with what is this.
Yes, sir. Yes.
Rohit sir, if you want to ask.
Okay, actually, one question from my side is, which data scaling method you have used?
So it is well differentiated hierarchy and the data set. It is available on the UCI repository.
No, data scaling. You have used some data
So
scaling.
data scaling is sorry sir. It is we have used standardized scaler. It uses Z score where it will reduces the value. It will reduces these variables. They will have 0 mean and standard deviation. तो उनकी वैल्यू को ऐसे reduce कर देगा तो उनका mean 0 और standard deviation 1.
Okay, so my question is how you applied, like to normalize the data scaling is kind of a normalization.
Yes.
So you applied the data normalization class wise, or you applied the data normalization on a complete data set?
So we have applied in on train and test and separately on train and test.
Okay. See.
So for each train they will have each class data set.
Okay. So in a way you have applied the data normalization on a complete data set, kind of. You have not segregated the class-wise data, then applied the data normalization on each class of the data. You have applied
yes, so we first prepare the fold, including both classes, and then we apply them.
Applied. Okay. So see, as you are doing your PhD, so it is better to do some more literature survey on that data normalization, because what my understanding is, if we are doing the data normalization by combining the data of all the classes, then the system will be biased. So we should do the data or feature normalization class wise, We will take one class of data, do the normalization, then take the another class of data, do the normalization. Because maybe for some class, a one particular feature will have very high value. For other class, it will be different. So you can check by implementing this strategy and see. Okay, the other part is you haven't applied any statistical test to prove to validate your result. No, no. Okay, so why I'm telling you, because you are a PhD scholar, you have to validate. You should validate your result with statistical analysis and statistical test. Okay. Okay, and then there are many standard data balance techniques. Some technique S mode, you may have heard about S mode.
Yes.
So why we are not using those standard technique?
So for like oversampling, you need a diverse data set, but this data set is so small. So, but how we will generate newer sample from this small data set?
No,
so they will not have so much diverse. They will not be so much diverse.
In that case, there are data augmentation technique that you can use.
So same way, data set small as so we can test out and try this also. We will see the data.
My suggestion is you should try everything and see if there is any overfitting. Then you may say, okay, this is not a good method to apply for. Okay, otherwise it's okay from my side. Thank you for your presentation.
Thank you, sir.
Thank you, ma'am.
Thank you.
Next is table ID 216. Miss Neha Pradhan. She will be presenting. So, please be ready. कहाँ है वो क्या वो उस रूम पे वो उधर से भेजी उधर स्नेहा
Hello, good evening everyone. Am I audible?
Yes, proceed.
Good evening everyone. I am Sneha Pradhan. I am currently pursuing my IMT in Electronics and Communication Engineering from National Institute of Technology, Sikkim. I am honored to be presenting our work titled A Novel Technique for EEG Signal Analysis Using EWT and CNN with Attention Mechanism, co-authored with my supervisor Dr. Gupta, Assistant Professor at Department of Electronics and Communication Engineering, NIT Sikkim. So I will be walking you through the motivation behind the study, the literature that has informed our model, a brief background on EEG signal, and our methodology involving empirical wavelet transform and CNN with attention mechanism. And again, we will be looking at last, we will be looking at the results and the contribution and the future directions that we are looking forward. Now, these are some recent studies that have laid the foundation of our work. Like some of them have used different machine learning models like SVM or random forest for seizure detection. Others have tried to implement CNN and also EWT for signal decomposition. No, not for EEG signal, but EWT has been used. So we have tried to fill this gap by implementing EWT CNN with attention mechanism through this study. So electroencephalography, or we say EEG, is a non-invasive method of recording electrical brain activity. It is critical for studying neurological disorders or conditions like epilepsy or even Alzheimer's. So our goal is to create a robust framework that can distinguish between seizure events and non-seizure events. That our system should also provide us high reliability despite the challenges such as EEG signals are non-stationary and noisy and multivariate. So we have traditional methods, but traditional methods often analyze EEG signals independently. So this leads to the loss of inter-channel dependencies. So we need a method that is adaptive and preserves this inter-channel dependency. So that's where EWT takes place, as it does not require any predefined basis function, and it is very well suited for EEG. So let us quickly see some common signal decomposition method that are generally used. So first we have Fourier transform. So Fourier transform has no time frequency localization. So thus it is not suitable as it will provide a same spectrum for both stationary and non-stationary signals. Second, we have wavelet transform. Wavelet transform requires predefined basis functions, so it is also not suitable due to the non-linear nature of our EEG signal. Now coming to the adaptive decomposition methods that are recently used. First one is the empirical wave mode decomposition. So this is a data dependent method, but the only drawback it has that it is not mathematically backed up by mathematical theory, and this method is not much robust to noise in the time as it is based on the time. Then we have empirical wavelet transform. So this is an adaptive wavelet decomposition technique, and it is much more noise resistant in the frequency domain. So thus we have used EWT, and EWT is also based on mathematical theory. Now coming to EWT involves 4 key steps. The first one being, first we are calculating the Fourier transform, then segmenting it based on the detected peaks, then we are constructing empirical wavelets as bandpass filters. The range is from 0.5 to 50 Hz, and then we are reconstructing the filter table. So this provides a very noise resistant decomposition of the EEG signals into very meaningful components. So we have used various statistical measures. These are the mathematical calculations that are involved. First of all, the calculation of minimum and maximum value. Then we have mean, standard deviation, and frequency domain characteristics for the peak detection. The fast Fourier transform is used to calculate the spectra, followed by the peak detection for segmenting. Now these segments help us to apply some custom filters effectively, isolating EEG subbands like delta, theta, and alpha bands. So these statistical measures, they give us an idea about the overall power or frequency of our EEG signal. So this overall power and frequency of our EEG signal help us to detect if there are any sudden spikes or rhythmic bursts present in our EEG signal. So about the database, so we have employed CHB Scal EEG database from PhysioNet. This consists of recording of 23 pediatric subjects. Each recording is sampled at 256 Hz, and each recording lasts from 1 to 4 hours per session. So the data is labeled as seizure or non-seizure episode, providing an ideal test bed for our classification model. The data has a total of 686 signals, out of which 141 signals are labeled as seizure event. So as you can see from the images itself, that there is some rhythmic burst in figure 3 that depicts our sample data for the seizure event. Now, what are we exactly detecting? So we focus on detecting various brainwave patterns like delta, theta, beta, and gamma. So these bands correlate with different mental and physiological states of our brain. Like delta waves ranging from 0.5 to 4 Hz associate with deep sleep and unconscious state. Theta waves associate with relaxation and meditation state. Alpha waves ranging from 8 to 12 Hz are associated with calm and awake state. Beta waves ranging from 13 to 30 Hz present active thinking and problem solving capabilities, and gamma waves that is greater than 30 Hz present high level cognitive functioning. So thus we are taking the bandpass filter range from 0.5 Hz to 50 Hz because that is our required range. Now our workflow include, first we have loaded a data set, then pre-processed and normalized it, and then we have finally extracted the features using the EWT, and then we have fed that features to our CNN with an attention layer model. So why we have choose CNN and attention layer model combination? Because not only it helps us in deep feature extraction, but also it helps us in focusing on selected features. Now these are the results. The model achieved an overall accuracy of 81.16%, with 97.35% being the recall value for our non-seizure detection. However, we have observed a lower sensitivity value for seizure events due to class imbalance and undersampling. So the ROC curve and our F1 score, they illustrate this performance disparity well, highlighting that there is an area for future enhancement. Nonetheless, our attention-based CNN model has stable learning generalization. The model is better than just some random guessing. So compared to existing methods that has been based on this data set, we have a model like EMB plus CNN plus LSTM, then a model of pure EWT and CNN. So our approach, it strikes a balance between computational efficiency and interpretability. While others, they achieve a higher sensitivity value, but it often require more complex architecture. So more complex architecture is unsuitable for real-time applications. So what sets our approach unique is first is the integration of EWT with attention-based CNN that allow dynamic weight feature weighting. Then for this allows us in improved interpretability that is vital for clinical trust. Then it has lower computational overhead, making real-time application more visible and better decomposition of EEG signals due to EWT. In conclusion, our framework has shown promise for automated EEG signal classification, particularly in filtering out the non-seizure events very effectively. Moving forward, we plan to address seizure detection sensitivity using class-weighted training or oversampling. We also aim to adapt this framework to other neurological disorders like Alzheimer. And also, we are trying to implement some transformer-based models because they have self-attention mechanism. So this can be optimized for real-time employment in clinical settings. So these are the references. Thank you for your attention. I would be happy to take any questions now.
Yes, Neha, you have very well presented your work and your PPT is good. So you have presented some mathematics also here. From my side, I want to ask one question to you. That is, if suppose there is some abnormality in your EG signal, means some
Yes.
false data is there. Okay. So is some abnormality is detected in your EG signal. So how it will be affect the voice of a child or anyone?
So, if you are seeing through like EEG signals, there are some patterns in EEG signal when a seizure is coming to a person. Like there would be a rhythmic oscillations in the EEG signal, or even see sudden spikes in our EEG signal. Behavior-wise, there are people react different. There are different behaviors of the seizures. Like some may be like for a newborn child, they are just constantly laughing. Or if we talk about other things that there is sudden abnormal movements in the body. So that's how an EEG, an epileptic seizure is detected in a human body.
You have taken all these data from human body or you have taken this random data?
So this data was available in Physionet. So we have taken from that the CFM IP scalp EEG database from Physionet.
Rohit sir, if you want to ask.
Okay, so Isnah, I have one or two questions to you. The first one is the frequency of this particular P6 hertz.
Yes, sir.
Okay, and you have not accepted any minimum technique. You have applied directly. You are given the signal to your deep learning model.
So for the pre-processing, we have used EWT. So in EWT only, we are filtering is done, and then the segmentation is done. So after the EWT, we have reprocessed the signal. So we have extracted features like standard deviation and mean of our signal, and then we have fed that features to our CNN model. So the data is not directly.
Hold on. So what is the windowing, that window size that you have taken?
So the segmentation was taken between 5 to 10 seconds. The segmentation window.
No, why between 5 to 10 seconds? There must be some particular value, no? 5 seconds or maybe 7 seconds or maybe 10 seconds.
So when I was observing our signal, so I thought that this, if we are taking some mode larger than 5 seconds, then we are missing out on some spikes. So that's why it was like that it is suitable for us to take 5 seconds as all the spikes could be detected in that signal.
So that means you have taken 5-second window.
Yes, sir, 5 seconds.
Okay, so 5-second window if you are taking, then in one window, how many samples will be there? It will be almost 1200 or something.
Yes, sir.
Okay, and based on that you are calculating the features.
Yes, sir.
And then you are feeding all those features to deep learning model.
Yes, sir.
Okay, so can you tell what is the advantage of deep learning model?
So using deep learning model, it would be like it just automates everything. Less human intervention is needed. Like if you are using models such as SVM or even random forest, So again and again that we have to, at some point we have to provide our data again. But this model, it just automatically works. We don't need to intervene much in it. Once the model, once our model is properly trained, then if you have the accuracy is good, then we don't need much of intervention in it.
See, the main advantage of all those deep learning models as compared to the machine learning model is that we don't have to extract the features. That is the most tedious task.
Yes.
Because there are so many features which to select, which not to consider, which to consider. That is one of the most tedious tasks for signal processing. And anyway, if you are extracting the features and then giving those features to deep learning model, that you have done that tedious task by yourself now.
Yes, sir.
So the main advantage of using the deep learning models are you don't have to do feature engineering, but here you are already extracting the features. Okay. Now the second thing is how many features you have extracted?
So we have basically taken out two major features are there: standard deviation and mean of our signal.
So that means for each window you have extracted two features.
Yes, sir.
So and now the another disadvantage of your deep learning model is it requires high volume of data.
Yes, sir.
But whether the data that you are giving to train your model is high volume or not,
So for
you can observe by yourself.
so that I have also mentioned in the conclusion that for non-seizure the data is sufficient, but for seizure detection
No,
the
one minute, hold on. When we are saying high volume means in terms of training what to say, event wise,
Yes, sir.
there must be more event. And also the dimension of the signal should be higher. Like there must be more features, not only two features. Because the input side, if you are giving two features only, that means at the input side you are having only two neurons. And then you are going to increase the size of all the layers and everything, and then you are going to again come down to two neurons at the output side.
Yes, sir.
So that you should look for. That is my suggestion. Okay. Other than that, the other question is this Caesar and non-Caesar data must be unbalanced.
Yes, sir, they are unbalanced.
So any technique you have think for to balance the data set?
The first one I thought about using SMART or even data augmentation firstly. If by data augmentation I'm able to solve the problem, then that's well and good. Otherwise, I'm trying to look for transformer-based models because they are much more effective in this.
Okay, so whenever you are going for data augmentation or any other data imbalance technique, please check your model should not be over trained, or you can say the overfed.
Yes, sir.
Okay, that you should look for.
Yes, sir.
And whenever you are doing any analysis, please apply some statistical tests to see whether actually your results are statistically valid or not.
Yes, sir.
Okay. Okay. So thank you. This is all from my side. Thank you for your presentation.
Thank you, sir.
Okay.
Thank you, ma'am. Next paper ID is 220. 220. Please be ready. Paper ID 220. Please present your screen.
Sir, is it this, sir?
Yes. Yes, please start.
Sir, good evening, sir. So this is Sarthak Nayak from Department of Biomedical Engineering from SRM Institute of Science and Technology. And today I'm going to present the paper ID 220 titled Reinforcement Learning and Explainable AI Framework for Fracture Risk Mitigation via Microtrauma Optimization using crowdsourced data. Fractures are a global health challenge, especially for the elderly, and they cause a lot of pain, and also it causes a lot of money every year. So, but many of these are actually preventable. Like traditional tools like fracture risk assessment tool relies on bone scans and which again takes bone mineral density into consideration. They are again like costly and are not accessible by any everyone, like mostly in rural areas. So what the solution that we propose here is reinforcement learning and explainable AI, and combining them both to target a parameter called microtrauma. So basically they are stumbles or near falls, which actually implies our poor strength and balance. So, and also like over time, the stumbles that we encounter every day, so it might result into like actual fracture. Basically, what we are trying to do is optimization of the like our lifestyle or behavioral data without the need of imaging every time. So. The past works like include the fracture risk assessment tool, which obviously like it's relies on the bone mineral density and also is like expensive and not accessible by anyone. Most of the people. The fall like risk studies implies that um, poor balance and like stumbles they can be they can imply that there is a early warning sign of the fracture, like we might encounter some fractures. And the reinforcement learning obviously like it's a booming field in gaming and robotics, and slowly it's expanding into healthcare sectors. Explainable AI obviously like there needs to be a system where the healthcare professional needs to trust the AI decisions about why the AI is working, and obviously it needs to be a transparent thing because it needs to be trusted in the healthcare sector. So the gap we have worked on is like combining both reinforcement learning and explainable AI to optimize the stumbles or microtrauma for prevention of fracture. So, this is the workflow. So basically, we collected the survey data from 120 participants, and we captured details like age, activity, and sleep, and also calcium intake. So we ran it through a reinforcement learning model, which runs a 50-week simulation across 20,000 steps. So it finds the best action about to reduce the microtrauma, and it's like a coach which learns the best practices to avoid the mistakes. So again, we use the explainable AI to actually make it more interpretable, and obviously to validate this, we used a five-fold cross-validation and split in all the split the 120 participants into like 96 for training and then 24 for testing. So we move on to this data collection that we did it through a Google form. So we collected age, activity, calcium intake, like sleep, all those parameters, and like we categorized some of the microtrauma to like 0.5, 2.5 or 4.5 events per month, like to reduce the bias. And these are the like graph. This graph shows the amount the participants, the amount of stumbles they encounter per month, and if they have a history of a fracture or not. So moving on to the simulation of the reinforcement learning that we made. So we used PPO or proximal policy optimization. This model takes action to reduce the microtrauma over 50 weeks. So it is like a recommendation system where it actually suggests some activities so that it moves to a safer lane, so that it gradually reduces the micro trauma. So the actions include, if suppose adding 1 hour of activity, it cuts the micro trauma is reduced by 0.25, or walking more, or including activity more in the or calcium intake more, or sleep. It reduces the microtrauma by 0.125, or simply no action because sorry, simply no action because the microtrauma is at a stable level. Actually, we derived this from a study, the activity reduces microtrauma by 25% and sleep by 12.5%. So um, moving on to the reward system, that if the microtrauma reaches zero gradually, so the reward is like plus 10, and if it doesn't reach zero, so minus 10 times the microtrauma, whatever the microtrauma is, it is normalized to 0 to 3 stages. For example, suppose the microtrauma is reduced, so that person will get a reward of 3. If it's less, I mean, if it's not somewhere around the middle or something, so it will give it will assign 1 or something. Or if the person didn't take any action at all, so it will assign as 0 or something. So also we the we use the PPO because it was the better among all the reinforcement learning methods to find that the perfect perfect way to reduce the microtrauma. Moving on to the explainable AI application in this in this framework. So this explainable AI actually makes some activities this highlights that whatever action that was taken by the model is it just justifies why it was taken, and what is the action that we have to do. So basically here it highlights that the activity has the biggest impact, 0.4, followed by age. If you are older, then the chances of fracture increases, and there are other factors as well. So these are scaled from 0 to 1, and depending on that, um, it gives the it suggests the activities. And for example, walking more every week improves balance or something. Maybe calcium taking more calcium intake will improve the microtrauma reduction. Alone activity won't help it. So with this a healthcare professional can tell confidently that the patient needs to work more, and so that it can reduce the risk of the fracture in a later stage. So to validate this, we performed the 5-fold cross validation. We divided the one.
Please go fast. Okay, we having limited time.
Sorry. So we performed the cross validation across it, and we found that it is scoring almost to the it is scoring almost a good amount of this, value. That it was ranged from since it was ranged from 0 to 3, so it's quite nearer to the that value. So the result that we shown is there is a 100% microtrauma reduction over the period of average of 13.5 weeks, and the cross validation shows that it's a reliable method, because action distribution by the machine, the reinforcement learning model shows that the activity is at 30% and calcium and sleep at approximately 25%, and no action that was taken is like almost 20%. So, like for example, a participant 9 with a microdroma 4.5, his microdroma reduces to 0 in 20 weeks due to the due to activities. So as you can see, these are the results that we got. Like the reward increased over the period of 50 weeks, and the microdroma reduced from 1.5, like gradually reduces, and the other figure shows the amount, the whatever the activity was taken. So this is the action distribution that I mentioned earlier, the figure, and the other figure like on the right is like a future work that we included just for an insight that using NLP analysis we can detect like if the patient is suffering from any stumbles or anything. So finally, like we got, like there are some limitations as well, like um, the since it's a like a starting phase, so we did the static survey data, and there are computational constraints as well, because there's a huge amount of like steps, like 20,000 steps, but it was like maximum we could do with our like computational limits, like 5,000 approximately. So this concluding this framework reduced microdroma to 0 in most cases, and since it's a unique thing, because we use surveys, and like with that, like we actually optimize the lifestyles of the people, so that they can avoid the fractures in the future. So the future work that we are planning is like maybe including maybe 1,000 participants, maybe expanding the data, and maybe like conducting a trial, like a dynamic with a dynamic data that they will put every month or something, and also maybe including the NLP feature, and like we can make it under a same umbrella, so that like people who don't have access to all those like expensive bone density scan, or all those like expensive measures, so that they can make use of this system to like prepare themselves beforehand, like save themselves, and also maybe this could be implemented into an app or a wearable device where we store data continuously. Like this can be a lifestyle feature. That's what we are planning to do. So thank you. These are the references that we do. Thank you. That was all.
Okay, Sarthak, you have a nice presentation. So, from my side, I would like to ask, I want to suggest you that in your literature survey, you should include the references as well. Means from where you have taken this particular thing. Okay. So just include the reference, and also you have in your research gap you have written that you have applied the combination of reinforced learning and this explainable AI. Okay. So this is not the research gap. Okay, you have to find where is the means technical gap. Okay. Then why you are applying this this reinforcement learning and explainable AI, you have to show that thing, that we have justified that this research gap is required, and we have implemented this technique to overcome that point. Okay. So this thing you should have to write it this way. Another, you should have to add the figure numbers as well. And I would like to ask that the data you have taken. So what type of variability is required to justify that we can avoid this means fracture in future. Okay, so what type of data is required? Is to improve the accuracy of your algorithm.
So, sir, like we need like daily data, like suppose like a form, every day like we'll record something, like not every day, it's like every week or something. So we'll record like this much calcium intake we took this time, and if you are doing activity or not. So there will be a parameter like how many times you stumbled or how many times you like almost fell down, or you hit suppose a corner of a bed or something. So this will this will be recorded as a number, okay, and so according to that the model will assign that, okay, for reducing this number of stumbles, and you have to increase the strength, so that how the strength will be improved with working more or doing more activity. Like obviously it is related to the cognitive functions. I mean, I won't put that. I won't dive deeper into that biology thing. But yeah, that's what ultimately like we will focus on.
So this data will vary person to person.
Yes, sir. Yes, sir. Person to person it will vary.
Rohit sir, you may ask something.
Yes, yes. Sarthak, one question is like, how many your participants who given the data who participated in your Google form, they know the micro trauma?
Sir, they don't know exactly the scientific term, but we posted the question as like how many times you stumbled across or how many times you almost fell down, like that.
Okay, so in that case, let's say if you ask me how many times I stumbled throughout the day, I don't remember.
We put the pointer.
No,
sir, it's a basically it's a approximate
okay, it's an approximated thing. The subject has to enter some approximate number with value, depending upon his memory. So already the data set that you are acquiring is having so much biasness.
Sir, we will try to reduce that.
What maybe you are planning to reduce that kind of biasness?
Sir, maybe category will make it encoded maybe categorical data, maybe something like that.
No, this is subjective biasness. The subjective biasness can be only reduced down by either designing some better questionnaire, indirect questions, or maybe introducing some sensors to identify all those events throughout the day. One thing. Secondly, what is your hypothesis to reduce down the this micro traumas? Like you said, if you increase the calcium intake, it will reduce down. If you increase the better sleep cycle, if you have better sleep, then this will reduce down. So likewise, what is your core hypothesis for this problem?
Sir, core hypothesis as in maybe sir, obviously we are taking the age factor into consideration, and during the day, obviously micro sir, suppose if we hit a certain if we fell down or something, so if we do it continuously, maybe we will encounter some micro fractures in the bone. So over the time the process that will that fracture will happen in the future.
No, my question was, sorry, I was not able to put the question correctly, maybe. So my question is, your reinforcement learning system is assuming that if you increase the calcium intake your microfractures will go down.
Yes, sir.
Is it correct?
Yes, sir.
Okay. So, what is the basis of that? You have any study? You have any prior research which is
Yes, sir.
this particular point? Okay, if you take proper sleep, your microfractures will go down. If you take higher calcium food intake, your microfractures will go down. Is there any study something like that?
Yes, sir. Yes, sir. We've taken it from doctor, sir. If we increase sleep, then it will sleep and calcium intake. Then it will reduce by 12.5%.
So, first of all, you should use that hypothesis in your presentation because that is the core of your work. Okay, and how the person is entering the response towards calcium intake question, like how much calcium you have taken, something like that. In questionnaire, we have one question. So, what is, let's say, if I am the subject, what should I enter?
Sir, there will be like suppose calcium intake as in like maybe you take a tablet or maybe you are taking some milk or something like that. So like we mentioned while giving the Google form out, we mentioned like suppose like if it's 500 ml then it's 1 unit or something like that. So we for a starter we did like that.
Okay, so for that also you should introduce more food items or maybe calcium supplements or something with their proper scientific proofs. Like if person is taking 500 ml of milk, then it should have that much calcium, something like that. Okay, so this is all from my side. Thank you for your presentation.
Thank you, sir.
Thank you.
Thank you, sir. I would like to request next paper ID 226 to present your presentation. 226.
Okay, we can move on to next presentation. The paper ID 226.
Yes, sir.
So, Anshul, you can share your screen.
Yes, sir. Yes, sir. So I'm S. Parikishri and I'm currently pursuing my BTech in biomedical engineering at the Saram Institute of Science and Technology. So I'll be presenting my paper AI-based prediction of atrial fibrillation using PPG and ECG data. So atrial fibrillation is like the most common type of arrhythmia. It's affecting a large number of people, over 27 million people globally. So basically it leads to irregular heartbeats, which is basically caused by disoriented or disorganized electrical signals from the atrium when propagating through the heart. It leads to stroke, heart failure, and dementia. So traditional diagnosis we use ECG recording, which is like tiny consuming. Yeah.
Could you please speak louder?
Okay, yeah, sure. Yeah, so traditional diagnosis uses ECG recordings, which is like time consuming, and manually looking at the ECG graph can also vary according to person. So it may miss intermittent or asymptomatic episodes. So AFib is actually very subtle and it's not very easy to identify AFib. So that's why we are incorporating AI-based diagnostic tools in order to so that we can detect AFib early and faster and more accurately. So PPG is another non-invasive method which measures the blood volume in the capillaries. So it is now used in a large level in wearable devices. So when PPG is more accessible, it also has motion marking pads. So it can impact the accuracy. ECG is gold standard, but it's not feasible for continuous have pre-analyzed both ECG and PPG physiological modalities in our research. So this, we are addressing the gap by infusing both the physiological modalities in order to diagnose cases, and also we are proposing a hybrid deep learning model that classifies age-group accurately. So we are moving on to AU and objectives. So our aim is to develop an AI model for early age prediction using EPG and ECG data. So first our objective is to collect and pre-process the physiological data. So we are gathering ECG and EPG data, and then we are applying pre-processing techniques for removable noise. We are segmenting the data and normalizing the models. Then we are training, we are using three models and do you want this? So we are using CNN, NFC, and FCC. So we are training CNN to capture the spatial features from both the modalities, and then we are using LSTM to capture temporal dependencies. So XGBoost is basically built in order to classify if it's age-group or normal signal. So here we are inserting the model, and then we are evaluating execution accuracy, precision, recall, and score, which is our performance metrics. So this is a literature review. We have done quite gone through certain papers which have similar studies. Most of the studies usually incorporate PPG only. And also some of the studies have used 2D CNN, which is like used only for image-based data. Right now, we have used 1D CNN. So, and some of the studies have used only ECG, which is like limiting the variable applicability. And some of the studies have reduced ROC curves, so that can indicate underfitting or overfitting. So here we have used Mimic Perform training dataset. It has like total 200 subjects, and 100 is like normal sinus syndrome, and 100 is for atrial fibrillation, evenly divided for adult and neonates. So this includes ECG and PPG signals, which is like sampled in the dataset itself at 125 hertz. So we have partitioned the dataset for 80% for training and 20% for testing. Before that, we have also segmented the signals so that it is easy for model development and evaluation. So initially, we have collected the data as told from the Mimic Perform training dataset, and we can see that the normal sinus rhythm ECG and has like distinct waves, whereas the distinct P wave, distinct R waves, and the QRS interval, but then age does not indicate that. So PPG signal in a similar way has RR intervals, whereas age PPG signal does not have the significant RR intervals. So then we have pre-processed the data, and then like we have included filtering, wavelet denoising to remove baseline model power line interferences. These are like basic filtering methods, and then we have segmented the signals into fixed durations for easy processing of the signals. And then the data set was split into 80% and 20% for training and testing respectively. So we used min-max scaling for normalization so that the values are in 0 to 1 range for like ensuring model stability. And then we move on to methodology. So like model development. So we initially give the ECG and PPG data, which is like the input data, to the 1D convolution layer, which has value activation layer. So like and there's like alternating 1D convolution and max pooling layers. 1D convolution is basically performs the convolution process between the input image and the filter, and then max pooling it reduces the dimensionality. So then these the output from the max pooling layer is given to the LSTM layer, which like captures the temporal dependencies, and it also knows like what kind of data has to be kept in the memory and what kind of data has to be discarded. Then it moves on to the dropout layer. So we have added the dropout layer because we want to ensure that there's no overfitting. So we part of the neuron is like removed randomly to generalize the data, and then we have flattened it, and then the flattened layer output is given to the XT boost, which is like an ML algorithm, and then it classifies the data into if it's normal sinus rhythm or atrial fibrillation. So then we have evaluated the proposed model using like key classification metrics like accuracy, precision, specificity, recall, and F1 score. So we have obtained results, and this is the accuracy and loss curve. So we can see that the training and the testing accuracy is like converging. So while the loss curve is like declining and it's showing at low levels. So this indicates that the model is not overfitting and it's generalizing well. So we also have the confusion matrix, which show that the false positives and the false negatives are very low in number compared to the true positives and the true negatives. So it indicates high model reliability, and there's also high accuracy. So this is the performance metrics of the individual models and the proposed model. So you can see that the proposed model is showing high accuracy, precision, recall, and F1 score compared to the other performance metrics of other like the individual models. So there's a better balance between like the precision and recall. So there's like high classification performance and good generalization. So yeah. So our model has high accuracy, precision, recall, and specificity compared to the other like studies that's done before, because they have like accuracy which range from 95 to 98%, but our proposed model has reached around 99.61% accuracy. So a major advantage is that we use multimodal data, that is ECG and PPG, whereas the other studies relied solely on one modality. And then, so yeah, this approach can be used for remote monitoring and also in cases where resources are limited. So our model is not complex also. It's like it does not require high computation, so it's suitable for real-time deployment also. And we have focused on cost-effective solutions over here. So early detection of AFib can prevent stroke and heart failure, so that's our primary goal. And it can also be used in wearables, which enables continuous monitoring and large-scale screening. So one of the limitations that we have used mimic from training data set over here. So in future we would like it only concentrates on adults and neonates, but in future we should validate on more diverse data, which includes all kinds of age groups. So yeah, then it could be applied for real-time deployment, and also it could be used in wearables. So we can see that our model has improved the diagnostic accuracy in case of for detecting atrial fibrillation, and the hybrid ensemble model which we have used also shows excellent performance, and it's non-invasive, computationally less complex, and then it can also be used in real-time deployment in places where resources are limited. So future work we will focus on incorporating it in wearable devices, and we also conduct clinical trials and improve so that it's adopted in a wider range. So yeah, thank you. These are the resources, these are the references that we have taken. Thank you.
Thank you, ma'am. Rohit sir, please, do you have any questions?
Actually, you have used that some data sets to train and test your model. And when you are presenting your comparisons, like the performance of your all three models, so almost all three models are having 99 point something accuracy.
Yes, sir. The precision and recall are like better compared to the other models.
Many applications are using 98 or 99 point something. So that implementing performance not have any cross validation any other methods. So you should do some cross validation, apply some cross validation methods.
Actually, we have done tenfold cross validation, sir. So in that also I have obtained the same accuracy precision. But I couldn't include the data over here due to slide constraints.
No. If we were doing 10 for cross validation, we must be getting 10 accuracies.
Yes.
So you can represent it as the average of those 10 accuracies and then the standard deviation between those 10 accuracies. So that a standard deviation will get more information. Okay, and one more thing. Why all the other authors have used only one modality, either ECG or what do you think?
I think they have concentrated more on either wearables or streaming continuous monitoring. They haven't done both. They're not into, like, they haven't incorporated both as the case. Maybe they are like, they are either saying, they are either focusing on only smartwatches, like to incorporate it, or they are focusing on using ECG in the hospital setting.
Okay, so my suggestion is you just check the performance of your model for ECG, it will be sleep and so you can check your model performance for ECG invisibly and NIT invisibly. Then you will confirm why researchers are using maybe either one at a time. Because biologically, both the signals are giving you the information about the heart activity. Both the signals are already correlated. That is one of the reasons. Okay, thank you. This is from my side. Thank you for your presentation.
Thank you, ma'am. Next paper ID 227. Please present your screen. Paper ID 227.
Just please do it faster. Maybe you will just join the please.
Election work.
Oh, sorry. यही था सर, इसी पे क्या हुआ? प्रेजेंट बोल दो
Mr. Arjun, please share your slides.
Sir, I think he is joining with some other laptop. Maybe it will take 1 or 2 minutes, sir.
Okay, sir. Good, sir. 3-4 मिनट लगेगा last time.
पासवर्ड का कुछ प्रॉब्लम हो गया और एक लैपटॉप पे
ठीक है, तो जो कंप्लीट चीजें एक साथ मिक्स हो जाता है तो मेरा दिमाग खराब होता है। एक तो एआई है ना, वो फिर भी समझ में आता है कि नेटवर्किंग आ जाता है और फिर बायो आ जाता है खत्म।
बायो में भी आज तो क्या सारा कुछ बायो पे चल रहा है।
बायो और एआई में तो है ही
ये है क्या
मतलब भी समझ में आता है नेटवर्किंग आ जाता है तो 3 पॉइंट है जहां जरूर किसी को इनका क्या प्रॉब्लम है?
उसका लैपटॉप का कुछ प्रॉब्लम है और एक लैपटॉप पे ज्वाइन कर रहा है बोल रहा है कि 1 मिनट बाद में
अच्छा इतनी है एक काम कर सकते हैं, इनका रिकॉर्डेड वीडियो है, इनको बोलिए कि हम लोग उनका रिकॉर्डेड वीडियो चला देते हैं। हाँ, और उनको प्रेजेंट रहना पड़ेगा उस समय। If he is replying to our calls, तो उनको रहने दीजिए, हम लोग वीडियो चला देते हैं।
And I'll be presenting the paper on design and analysis of low power EEG amplifier using bidirectional OTA in affiliation with the School of Electronics Engineering VIT Vellore. Before starting, I would like to thank all the organizers for this opportunity for presenting our work on this platform. So let me just give you the session outline, something which we will be focusing in. So we'll first introduce, then we'll see the methodology on how we discuss and develop the OTA. Using that OTA, we have designed and proposed the in-house EEG amplifier, and then we'll be comparing the current work results with the previous work in the past, and then we'll conclude and we'll discuss the future scope of the paper as we can see. So, in basic introduction, if you see the biomedical applications in today's world like EEG or the AFE that we use, require very low voltage and low power specifications. The reason behind that is the human body is not very suitable to work at very high voltages. Therefore, any specific design that we are developing for the human body has to be low voltage and low power consumption because of the safety measures that has to be taken by developing the system. So, the technology for the biomedical applications have recently moved in the past 5 to 10 years because of the United Nations declaring it as an SDG. So if we look into the system, how the current applications are working, we see that op-amps, OTAs, etc. There are some CMOS technologies that we use for developing filters and amplifiers in the system. The major reason after the research that we did, we found out that voltage plays a very important role when we look into the output. So the input voltage is very much dependent on how the output is going to look. So voltage plays an important role, and basically when we are communicating with the human body, we need to make sure the voltage is very less, because human body at high voltage can cause hazardous life-threatening issues as well. So in this technology, when we want to go for a low voltage design, we basically try to explore the technologies, and we came across belt-driven technology, which gives us the capability to work on very low voltages, and we can still achieve the goals that we are trying to do. So we try to implement the circuits using belt-driven technology in our paper, and we try to accomplish the same goals that others have tried to accomplish, but using the belt-driven technology. So the basic methodology on which how we develop the operational transfer amplifier is basically OTA is a voltage controlled device which converts the input voltage to output, and OTA basically be designed in such a manner that each PMOS that you see on the in the circuit is just a simple PMOS declaration, but when we use bulb driven, we use a set of PMOS and NMOS in it. So this is the simplified circuit. If we want to expand it, every PMOS will have a set of PMOS and NMOS as a set, and the circuit expands a lot. Just to keep it short for the presentation, I tested the normal circuit here. So the basic working I have explained in the PPT, that when the input, like the positive edge and negative edge voltages, when they combine and when they are equal, the set of first 4 and the last 4 PMOSes tend to have the same input level, and the input mode, if you see, we have used current mirroring, as it is very obvious that you can see the current mirroring has been used for the PMOS and NMOS designs. So even if we change the input sources, the PMOS operates in such a manner that the current mirroring does not affect the output in the case. And apart from this, we can see the simple calculations have been attached in the PPT. I am not very much sure about the calculations because it was not done from my end. The calculations were done by the other authors and people who supported me. So I'm not very much sure about how I can explain the calculations to you. But yeah, so the basic OTA was designed from a basic circuit. We took the belt-driven technology and rail-to-rail, and then we combined it and tried to implement it. We have the results for the separate OTA that I will discuss later in the slide. Using this OTA, I designed another EEG amplifier that can be used in real life. So we did not test it with EEG input as of now, but we are on the stage of testing it with real EEG like EEG signals, and then we can test the output. I'll just briefly give you how the EEG amplifier has been designed. So we are using two voltage inputs, positive edge and negative edge, and we have a set of NMOS in the input. We have chosen capacitors because it is not necessary for us to use a capacitor, but we know that when we are using a voltage source, it will give DC offset that is going to get developed. If we do not pass it through a capacitor which acts as a filter, it is going to affect the output. Therefore, the output will not have the linearity we expect, but it is going to be distorted, which we don't want, because the EG signal is very minute and very streamlined, so we don't want the distortion to happen. Apart from this, we also took the signal attenuation in mind for keeping the values of capacitors. So we calculated a rough range in which the capacitor value should lie, and based on that we set so the range was calculated, and then using combination with combination, we got to a value of 100 picofarad for the capacitor that has been attached to the voltage input, and for the feedback of CF we chose a 50 picofarad. Same feedback capacitors have been attached from the output to the input as C2, which has been tuned in such a manner that the output comes in a specific range that we did in the calculations. So the output was expected to come in the range of picofarad. So we had to tune C2 in such a manner that we get to a state of picofarad in the reasonable range of the OTA. So we have set it as 2 nanofarad, like 2 × 10⁻⁹ farad value. Apart from this, the best part is that this proposed EEG amplifier, when we ran it on Latest Virtuoso, that is the software that we use for the simulation of entire project, it gave us an upper hand on the gain, bandwidth, the output noise, the phase, and these are all the 4 parameters that I have considered in this research to compare other works, because we need standard parameters to compare our work with the different works, to compare that whether this work is actually viable and it can go production or it is just a piece of work that we have done. So these are the output and the phase and amplitude graph for just the OTA when we ran. The results are in the tabulation and just show it. This is what we have done for the EG amplifier separately. So when we compare this work with the previous works, so we can see that 0.5 volt is the operation for both OTA and EG, and the comparative study shows that certain points the work is very good, certain points we are yet to achieve, but we are sure that once we keep this fine tuning, we will be able to achieve all the parameters compared to the previous work. So from the literature, it is very much clear that power consumption and noise has reduced significantly in the EG amplifier, while it is consuming very low power. That is the best thing that we can say, because low power is very much suitable for the human body, and when we are talking about signals from the brain, we have to keep it very low so that there is no interference from our chip or from our technology into the natural signal that is coming from the brain. And apart from this, it gives an optimal balance and prevents the integrity of the original signal. So even if I want to conclude it in very short, the paper gives the design of an OTA using the bulk technology, where the control has been shifted from the gate of a MOSFET to the body, that is the bulb, and we have categorized it into very low voltage and low power consumption, which very well fits as per the result that we obtained. Apart from this, the OTA operates at 0.5 and dissipates to 30 nanowatt of power, has been simulated in cadence virtuoso with 90 nanometers of CMOS technology that we have used, and the OTA has been used to design an in-house state-of-the-art EG amplifier, which also operates at 0.5 volt and dissipates 675 nanowatt of power, which is comparatively very less as compared to the other papers that we have compared. If we talk about the future scope, it is just not the EG amplifier, that EG signal that we are focusing. We can even go for ECG, EMG, and other signals as well, and we can have a multi-parameter health monitoring system. As it is very linear and very compacted design, we can easily implement it in IoT, which gives us the capability to connect to cloud, which gives us the capability that we can evenly monitor a patient from anywhere in the world with a complete monitoring system with real-time data, which helps doctors, nurses, loved ones, and anyone can see the data of a patient and the condition of the patient anywhere in real time. Plus, we can have a safety feature of a threshold which we can set so that we can use this technology to prevent any loss which can happen to the human body in future, because it gives a pre-alarm to us if we talk about the environment. So this is the nutshell of the design that we have developed, and the references I have attached over here. And thank you so much. If you have any questions.
You are going to have a nice presentation. So just I want to ask three questions. What will be the impact of switching losses or switching delay on this amplifier output?
Okay, so
Because you have used the CMOS technology, so that is very fast. But you are using so much of switches, so the combined there may be some delays, or there will be some losses, and you have mentioned that there will be 675 megawatt of power is there. So what will be the impact of switching losses or the delay on your EG signal amplifier?
So basically, when we look into the multiple switching that is going to happen, I accept that it is going to have that. So because of that, a delay is going to come in the signal that is going to the EG amplifier in the beginning. But we tend to think in such a manner that when we discuss on simplifying the circuit more, we have a plan of making the circuit more compact and simple, where we can have less number of elements but with the same amount of output to be achieved. So the original circuit that we took, we simplified it to this extent. We are trying to simplify it to more extent so that there is not much switching into the original circuit. That means the OTA is going to have very less delay and less power dissipation. So when the signal goes from the OTA to the EG amplifier, there will be slight delay that I accept, but we try to reduce it with the number of switches reducing, the number of gates will also reduce, and we also tend to explore other than bulk driven technology. If we we can combine ray to rail or any other two technologies which can help us cut short the delay. We'll try to implement that. That is still in the pipeline. We didn't try it, but yeah, we have a plan.
How you will decide the output capacitance value that you have indicated by the CL?
Yeah. So basically, for the input and the CF, for that we did a small mathematical calculation based on the previous researchers' work we saw. Basically, the mathematical calculation I didn't carry out. I was just provided with the exact range of it, so I don't have the clear belief on how the value is being set. But I was given a range of capacitance value, and I was the one who did the combination and combination. I can get back to you with how the calculation was exactly done for the input and specifically for the output as well, because output capacitance CL is also there. I'm not very much sure how to do that, so I'm sorry for that.
Okay, thank you for your presentation. My one question is, which tool you have used to implement this?
We used cadence workflow for the simulation. And 19 nanometers is the technology that I use for both EEG and the.
Okay. And have you estimated the CMRR for that circuit that you have implemented?
CMRR, yes, I did a rough calculation, but I didn't upload it in the PPT. No, I don't think it is in the paper as well. But the CMRR, we did the rough calculation, but there was a lot of fluctuations when we took the readings for it. So we are still yet to do the fine tuning of the CMRR. If we have the CMRR, yes, it is with the Marshall study.
So please do all those calculations, and maybe you can incorporate all those things like this parameter in your presentation as well as your research work. The other thing is, see, whenever you are presenting any result or anything, this may be done by your other group member or maybe previous author. But if you are presenting, then you should take the responsibility for that. Never say like, okay, this is done by someone else in your research. Don't say that. You read it. If you find it okay, then only you should discuss or present it. Okay, so thank you for your presentation.
Thank you, sir. Thank you, sir.
Thank you, Dr. Rohit, sir, for your time.
Thank you. Thank you.
Now we would like to ask Dr. Gupta to felicitate Dr. Vivek.
Just a moment. Take the mic. बैटरी यहाँ चार्ज में लगा है, ये रखा हुआ है, इसका बैटरी और चार्ज, तो बैटरी में चार्जर यहाँ है, ठीक है, यूज कर लोगे तब तो, ठीक है, यूज करने के बाद ही ना लगाओगे, यूज करने के बाद होगा, हाँ, नहीं अब करोगे उसके बाद लगाओ। अभी तो उसके बाद तुम अगर ले जाना है विसर्जन करोगे वही चार्ज में लगा के और वहीं पे कैमरा लगा देना, ठीक है सर? तो फिर तुम लोग को लेके जाना होगा, चलो ठीक है? नहीं अरे क्या प्लान क्या है
सर बोले बस फोटो लेके जाना है, ये बताएं।
हाँ कितने बजे जाएंगे? कितने बजे जाएंगे? ए सुनो हेलो मैं बोल दूंगा कि मैं बता देगा क्या बोल दिया मतलब एक प्लेसमेंट देखिए यहाँ कहाँ ये कि नहीं इसको ये जा रहा है कौन वो तो जाएगा ये सुनकर वो तो जाएगा तुम भी जाओ ना वैसे भी टाइम नहीं आया क्यों तब मैं बोल रहा हूँ ये टेबल कहाँ से रहता है
हाँ ये एसीसी ऑफिस में
वो बैकअप करो मैं फिलहाल कैमरा लेके जाता हूँ उस रूम में लेकिन सारा कुछ अनाउंस करने के बाद टीम को बात ये सब शेयर करना पड़ेगा अरे तुम चलो ना क्या प्लीज सर ये इंसिस्टिंग नहीं है ना कमेंट